Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Today also we decided that we will solve linear charge distribution, that is due to thin rod at a point, right? But
Yes, sir.
but today we said we will not make it a symmetric charge distribution, not charge distribution, symmetric geometry, right? So,
Yes, sir.
so basically we can say electric field due to So yesterday we said electric field due to a thin rod on the equatorial line.
Yes, sir.
Right? So electric field due to thin rod at a point on the equatorial line. Here we are seeing electric field due to thin rod. That's it. Okay. Electric field due to thin rod.
Yes, sir.
So let us say this is my rod. Okay. Let us say my rod is from A to B, from here to here.
Yes, sir.
And the entire of the rod contains a charge, capital Q.
Yes, sir.
Now, I'll choose a random point rather than midpoint. I'm choosing a random point C, and at a distance of A from C, perpendicular to AB, let us say we have a point D. Okay.
Yes, sir.
I need to find the electric field. Due to this entire rod at the point D. Clear?
Yes, sir.
So, what will we do? We will say song, right?
Mm.
So, for the song, what is the first thing?
Let there be a reference point.
Reference. So, basically, let's see with the reference point, correct?
Yes, sir.
And I'll take at a distance of x, let us take small l, dx.
Yes. And there's DQ.
The charge on this particular element, let us say is dq.
Lambda equal to DQ by dx.
Lambda is equal to dq by dx. And due to this dq charge, we will say we need to, let us say the electric field at point D is D, right?
Yes, sir.
And if this angle is theta, then this angle is also theta, correct?
Yes, sir.
So we can take components. On this side, I will have dE cos theta, and on this side, I will have dE sin theta, correct?
Yes, sir.
Fine. Now, also one point, we have to
take the length of AB. So let us say it is given that length AC is L1 and length CB is L2. Okay.
Yes, sir.
That means from here to here it is L1 and from here to here it is L2. Okay.
Yes, sir.
So these are the given things. So we'll again figure out what is it that is exactly given to us. There is a uniform charge distribution on a thin rod from A to B, and we need to find the electric field at a distance of A from some random point C, right, perpendicular to AB, okay, due to the entire of rod. And it is given the total charge on the entire rod AB is capital Q, and the length AC is L1, the length CB is L2. Clear?
Yes, sir.
So this is our question. Now we are starting off our solution by saying at a distance of x, let us take a small element of length dx carrying the charge dq, and the electric field due to this small element at this point is going to be d away from this charge. And yesterday we said after getting dA I cannot directly integrate dA because
The direction is varying.
direction is varying. So as the element is varying along this rod, the direction of the electric field dE is going to vary. And we cannot integrate a vector whose direction is changing because integration is scalar addition.
Yes,
I
sir.
cannot do the scalar addition of a vector. Is this clear?
Yes, sir.
Next, therefore what I am doing is I am taking the components of this vector such that I am fixing the direction. That means if I talk of d cos theta component, the direction of d cos theta for every element is going to be from left to right.
Yes, sir.
And if I talk of d sin theta, the direction of any element will be along a vertical line. Upward, downward is different thing, right? But it will be along the vertical line. Is this clear?
Yes, sir.
Now, yesterday we discussed after taking components, we can do individual integration. That is fine.
Yes, sir.
All right. Now, first what I will do is, because all of these dimensions are already given, I will take this angle as theta 1 and let this angle is theta 2. Are you getting my point?
Yes, sir.
Right? So the idea is we can talk of the total rod in terms of theta 1, theta 2, or we can talk in terms of L1 and L2. Correct?
Yes, sir.
Okay. So fine. So first we can do, let us do d cos theta. Okay. So we have integral of d cos theta. If I'll take this as I cap and this as j cap,
Yes, sir.
I can say what I am trying to find in integral dE cos theta is nothing but electric field along x direction.
Yes, sir.
Also, I am just defining, we said uniform That means lambda is constant, right?
Yes, sir.
And that lambda will be what? Total charge upon L1 plus L2. And it also will be small dq upon dx. Is this clear?
Yes, sir.
Just I am defining it so that we can use it while we are solving the problem. So what is lambda? Lambda is first, it is because it is uniform thin rod. Lambda is constant, right? Next thing is, what is the value of lambda? Total charge is q. Total length is L1 plus L2. So I can say it is q by L1 plus L2.
Yes, sir.
And also another thing, for this small element, the charge on this element is dq, the length of this element is dx, therefore I can take it as dq by dx, correct?
Yes, sir.
Fine. So I am starting off with integration of dE cos theta. Now all I have to do is figure out if I have to convert in terms of theta or x, right? Yesterday we did the substitution. So what is dE? dE is equal to,
Sir, K dq by
k dq by, I will,
under root L2 square plus A square.
yeah, I will draw the triangle because anyways we will use the triangle in future also, right? Okay, so here we need to find what is the electric field at point D. Now here I will draw the triangle. So how will the triangle in this case come? Horizontal line, vertical line, and this is the line joining, right?
Yes, sir.
This is my x, right?
Yes.
And this is my a. What is hypotenuse? Hypotenuse is square root of a square plus x square, correct?
Yes, sir.
And this angle is theta. Fine.
Yes, sir.
So here I'll get k dq by this hypotenuse distance whole square. So it will be a square plus x square.
Yes.
So let me substitute it over here. Integral of k dq, k dq upon a square plus x square into cos theta. Fine.
Yes, sir.
Yesterday I told you one of the ways of doing integration in physics is always follow the geometry first. Mostly we will get the thing from geometry only, right? So according to my geometry, I have tan theta is equal to x upon a.
Yes, sir.
That means x is equal to a tan theta. And whenever I substitute, I need to differentiate. So dx is equal to a secant square theta d theta, correct?
Yes, sir.
Now, yesterday what we did, yesterday we also substituted cos theta is adjacent by hypotenuse. Now, and then again we got it in terms of theta to integrate. So why should I do 2 times? So I will let that cos theta be as cos theta only and bring my x and dq in terms of theta, right?
Yes, sir.
Also we have dq is equal to lambda dx. Correct?
Yes, sir.
So after substitution, what will this entire thing will become? K lambda in place of dx. dq is lambda dx, right?
Mm.
In place of dx, what will I have? A secant square theta d theta into cos theta divided by, in place of x, I have a tan theta.
Yes, sir.
So I will get a square over here into 1 plus tan square theta. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Secant square theta will cancel.
Mm.
1a will cancel with 1a over here. So if I can write here, I'll get k lambda by a, right? Correct?
Yes.
K lambda by a integral of cos theta d theta. Is this clear?
Yes, sir.
Cos theta d theta. So let me explain what I did from this step in this step. So Ex, that is electric field in the horizontal direction, is integral of dE cos theta. Correct?
Yes, sir.
Instead of changing anything in cos theta, I let it like that only. dE I substituted as k dq by distance whole square. That becomes a square plus x square. Correct? From here to here.
Yes, sir.
From the charge to point.
Sir,
Then,
here,
yeah.
when we put limit, should it be from 0 to theta 2?
Then,
As theta, so should it be from 0 to theta because cos theta is only until there?
see, I know, I understood. So what you're saying is what should be the limits of theta, correct?
Yes, sir.
See, in theta, if you take 0 to theta, you're considering only this much from here to here.
Yes, sir.
There is a rod in the upper side also, right?
Okay. Right, sir.
From A to C, we have a rod, right?
Yes, sir.
So if I take only from 0 to theta, I'll consider only this part.
Yes, sir.
So my limit should be what?
Should be twice of it.
This is not a symmetric rod.
Yes, sir.
See, what is theta?
It should be theta to theta.
What is theta? What did we define theta as? Theta is the angle from this reference line in the anti-clockwise direction. Correct?
Yes, sir.
But my rod is starting from here. So it is and it is going in the clockwise direction. It is going till here.
Yes, sir.
Anti-clockwise theta I have taken as positive. So the clockwise fellow will become.
Negative.
So if my reference, what is theta? From this reference line in the anti-clockwise direction. But I have to consider the entire of rod. That means I have to start from here and go till here. Correct?
Yes, sir.
So my limits of theta will be what?
Theta 1 to
Minus theta 1 to theta 2.
Yes, sir.
Why minus theta 1? Because from this reference line, I am going in the clockwise direction. So theta is anti-clockwise, which we are saying as positive. Now if I'll go clockwise, that means reverse of it, negative.
Yes, sir.
Correct?
Yes, sir.
So my limits will be this will be minus theta 1 to theta 2. Is this clear?
Yes, sir.
Fine. So now we came to k dq by a square plus x square cos theta. Right?
Yes, sir.
What is dq? dq is nothing but lambda dx from here, right?
Yes, sir.
dq is equal to lambda dx. Next, from the geometry, we got tan theta is equal to x upon a.
Yes, sir.
So x is equal to a tan theta. Right?
Mm.
Whenever we substitute, we differentiate. So dx is equal to a secant square theta d theta. Clear?
Yes, sir.
Now, here I have dq,
Yes, sir.
which is lambda dx.
Yes, sir.
So I substituted lambda, and in place of dx, I have a secant square theta d theta.
Yes, sir.
In the denominator, I
Yes.
have a square plus x square, which is a square tan square theta.
Yes, sir.
Taken the a square common, it becomes 1 plus tan square theta.
Yes, sir.
And from previous, I already have cos theta.
Yes, sir.
Secant square theta will cancel.
Yes, sir.
1a will cancel with 1a over here.
Yes, sir.
This story will become k lambda by a integral cos theta d theta.
Yes, sir.
Limits from minus theta 1 to theta 2. Clear?
Yes, sir.
Integral of cos theta is
Sin theta.
sin theta. So my answer will eventually become k. What is lambda? Capital Q by L1 plus L2.
Yes, sir.
Because capital Q is given, L1, L2 are given. I am coming to that. So in place of lambda, I can put capital Q divided by L1 plus L2. Correct?
Yes, sir.
In denominator, I already have A. Here I will get sin theta. Integral of cos theta is sin theta. And the limits from minus theta 1 to theta 2.
Yes, sir.
So my final answer will become kq by a into L1 plus L2. Here I will have sine upper limit minus sine of lower limit is minus theta 1, right?
Yes, sir.
But sine of minus theta is minus sine theta.
Yes, sir.
Therefore, this becomes plus and sine theta 1. Is this clear?
Yes, sir.
Now, next. Shall we move ahead?
Yes, sir.
Next is I want to find EY, electric field in the vertical direction.
Yes, sir.
Simply have to do integral of d sine theta, correct?
Yes, sir.
Now remember, if I will do k dq by a square plus x square, and this entire thing is going to be the same, correct?
Yes, sir.
So I'll simply write it k. In place of dq, I have what? Okay, I'll first write it off and then substitute. Okay, a square plus x square into sine theta, correct?
Yes, sir.
No, integral of k. In place of dq, just like here, what will I have? Lambda. And in place of dx, I have a secant square theta d theta into, I have a sine theta outside, correct?
Yes, sir.
Whole divided by, we have a square plus x square, which is a square into 1 plus tan square theta. Is this clear?
Yes, sir.
So simply this fellow will become k lambda by a, correct?
Yes, sir.
Which is same as this story. So kq by a into L1 plus L2, and it is here integral of sine theta d theta. Fine.
Yes, sir.
Limits will be the same, minus theta 1 to theta 2. Is this clear? Understood.
Yes, sir.
What is integral of sine theta?
Minus cos.
Minus cos theta. So we will have kq upon a into L1 plus L2, and due to integral sine theta I will get minus cos theta. What is the limits? Minus theta 1 to theta 2. Correct?
Yes, sir.
In place of cosine, cos of minus theta is cos theta. Right? So here, that's why I will get cos theta 2 minus cos theta 1. Correct?
Yes, sir.
But there is a minus sign outside also. Correct?
Yes, sir.
There is a minus sign outside also. Here, what should I get? Cos theta 2 minus cos theta 1. But because
cos theta 1 minus cos.
so my final answer will be kq by a times L1 plus L2 into cos theta 1 minus cos theta 2. Is this clear?
Yes, sir.
Ultimately, what is the electric field vector at point D? It is nothing but Ex I cap plus Ey j cap. Correct?
Yes, sir.
I found out Ex, I found out Ey, and the resultant vector Ed bar is Ex I cap plus Ey j cap. Is this clear?
Yes, sir.
Understood?
Yes, sir.
See, I'll just give a brief of what I did. Nothing different, same substitutions, same geometry, except for the symmetry. Same element, same conversion to theta, and very important thing for today is that I have to understand in theta also I am defining the reference first, because I need a song for that calculus also, right?
Yes, sir.
So let this line be the reference line, and let theta be the direction anti-clockwise positive. Okay?
Yes, sir.
Therefore, my limits of theta will be, if you imagine, it's going tick, 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 going clockwise.
Yes, sir.
If I say anti-clockwise positive, that means my limits are going to be tick, 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 minus theta 1 to plus theta 2.
Yes, sir.
Is this clear?
Yes, sir.
So yeah, so what we are saying is the net electric field due to the thin rod, right? The net electric field due to the thin rod at a point D resultant can be written as k lambda by A. That means I am taking my q by L1 plus L2 as lambda, right?
Yes, sir.
So k lambda by A. Now in brackets I have sine theta 1 plus sine theta 2 I cap, correct?
Yes, sir.
Sine theta 1 plus sine theta 2 I cap plus cos theta 1 minus cos theta 2. Just check it. Is it correct?
Yes, sir.
Cos theta 1 minus cos theta 2 j cap. Or is this theta 2? Just check it once.
Correct, Alice.
Clear? Right?
Yes, sir.
See, this is our general formula, general situation. From here, I can discuss special cases. So first, what special case I want to take? Let me make it a symmetric one. Okay. So first I will make it a symmetric rod where the total length, that means my L1 plus L2 according to this case, I will take it as capital L. Right?
Yes, sir.
And because of symmetry, I have theta 1 is equal to theta 2.
Yes, sir.
Correct?
Yes, sir.
So let me take this theta 1 is equal to theta 2 as some theta. Right? As some theta. So this becomes yesterday's problem.
Yes, sir.
Therefore, my net electric field E bar is equal to K lambda by A 2 sine theta I cap. Correct?
But sine theta component should be cancelled.
We will do that. Sine theta, what should be cancelled?
Components.
We'll do something about that. Components
Yes.
should be cancelled. We're already writing in terms of components.
The sine theta component should get cancelled.
Yeah. Right. See, yesterday the theta that we have taken, actually yesterday's theta, today's theta is the same. See, sine theta components which got cancelled, cos theta component after integration, that cos theta became our sine theta.
Yes, sir.
Okay, so don't confuse what you said is correct only. In the sine theta components are cancelled.
Yes, sir.
Cos theta components are adding up, right?
Hmm.
After integration, that cos theta becomes this fellow.
Yes, sir.
Fine?
Yes, sir.
Okay, so E is equal to K lambda by A 2 sine theta I cap. And here, if you remember, 0 J cap.
Hmm.
These are those sine theta components which get cancelled.
Yes, sir.
So, what do we have here? We have 2K lambda, right?
Yes, sir.
In place of sine theta, in this special case, how will the figure look like? The figure will look like this, correct?
Yes, sir.
This fellow is L by 2 because total length is L, and because of symmetry, that means we have our L by 2. This fellow is A,
Yes, sir.
and this is my theta or theta 1 or theta 2, right?
Yes, sir.
Wrote it as 0. Okay, fine.
Yes, sir.
So my sine theta actually from here is what? Opposite. Yeah.
Yes, sir.
Is this clear?
Yes, sir.
So basically I have 2k lambda by A into sine theta is L by 2 divided by under root of A square plus L by 2 whole square. And this is my I cap. Correct?
Yes, sir.
In the yesterday's problem, it was in upward direction. So this becomes J cap over there.
Hmm.
Correct?
Yeah.
See, I just want to explain one thing. Also,
That was tilted.
Also, lambda we can write it as q by a. All those things we have done yesterday.
Yes, sir.
So, from here we can rewrite however we want in terms of whatever we want. So why I gave yesterday the horizontal rod horizontal and today we have the rod as vertical is for your clarity purpose. Usually what happens is if I keep the rod horizontal and take some theta and all, that geometry is fixed in my head, but not the song properly.
Yes, sir.
So the song yesterday and song today is the same. Only today we are watching it, 90-degree anti-clockwise.
Yes, sir.
Right? So basically we got in symmetry we got the story like this.
Yes, sir.
In this also I can have subcases. If the angle subtended, what is the angle subtended at the center? 2 theta, right? Because this
Yes,
angle
sir.
is also theta.
Theta plus theta.
If the
Yes, sir.
angle subtended, 2 theta by the rod at the point is 90-degree.
Yes, sir.
So that makes this entire big fellow also a right angle triangle.
Yes, sir.
Right angled isosceles triangle. This entire thing will become 90-degree. Correct?
Yes, sir.
If 2 theta is equal to pi by 2, that means theta is pi by 4. So my electric field E bar I can write as in this subcase. From here I will take it down. Okay, so 2k lambda by A sin theta.
1 by root 2, that is 2. I mean, there's 2.
Right? So you
Okay,
can
yes,
do,
sir. Yes.
so basically you can do k lambda by A root 2 I cap. Right?
Yes, sir.
Next. Another subcase I can write over here as if my theta 1 becomes 0 and theta 2 is 90-degree. That means there is no rod in the upper side, whereas on the lower side we have rod till infinity. Above this horizontal line there is no rod. Above point C I have no rod. Here I have no rod. Theta 1 is 0 means upper side I don't have any rod. Correct?
Yes, sir.
And on the lower side, how much rod do I have? From point C to infinity. Because this is infinite only on one side, this is also called a semi-infinite wire. Semi-infinite wire is
But
this.
it is having a fixed theta.
But it is,
Or you gave theta to us 90 degrees. So it's working. Yes, sir.
is this clear? Theta 2 will eventually become 90-degree for
Yes, sir.
one semi-infinite wire. Fine?
Sir, how can the electric field be?
Let us see how much it is.
Yes, sir.
But is this clear? Theta 1 is 0, no rod on the upper side. Theta 2 90, rod till infinity. Correct?
Yes, sir.
And that is called semi-infinite wire. That means if I have infinite wire on one side, I can call it as semi-infinite wire. Okay? So what will this fellow become? My E bar is equal to, see, let me begin from here. Okay? So I have k lambda by A Sine theta 1 is 0, right?
Yes, sir.
So I'll just write it as 0 plus sine theta 2 is 1, right?
Yes, sir.
Or else I'll substitute this story. Okay. So I have sine 0 plus sine 90, correct? And this
Yes,
entire thing is I cap
it will be I cap plus
plus
no.
cos
Yeah.
0
Yeah.
minus cos 90. This is also there.
Hmm.
J cap. What are you saying?
It will be I cap plus.
It will be I cap plus J cap. So I just want to show the diagram. There is no rod on the upper side, and at a distance of A, we are finding this is infinity, right?
Hmm.
In this case, we can see that there will be electric field on both sides, and that is what we are getting as I cap plus J cap, correct?
Yes, sir.
And it is K lambda by A. K lambda by A, I cap plus J cap. K lambda by A, I cap plus J cap. So, one thing here I want to mention, if suppose due to semi-infinite wire, in this direction, if I want to know how much is their magnitude, K lambda by A.
Hmm.
In this direction, how much do I have? I'll have K lambda by A. Is this clear?
Yes, sir.
Take it till here. Here, this is important for our problem solving. Semi-infinite wire along I cap also, along this direction also I'll have K lambda by A. This direction also I'll have K lambda by A. Suppose I will switch this from bottom to top. Then also we'll call it semi-infinite wire. If nothing is there in bottom and only top is there.
We get theta 2 is 0 and theta 1 is 90.
Yeah, but rather than doing, I would rather suggest imagination.
Multiply minus.
Yeah, we can. That's what. But what I'm saying is instead of instead of going right from there, for a semi-infinite wire, if I remember these two fellows, if you remove from here and place it above, what will I say? Due to that, I should have a sense of direction for this vector, right? So if it is here, that means the field has to be somewhere over here, right? In this direction. Then I will say downward K lambda by A, right side K lambda by A.
Yes, sir.
So what I'm trying to say is that the reason I drew this right now is also important because we are going to play with these things. So I have a third subcase, right?
Yes.
So we have a third subcase where we have
Points are infinite.
yeah, so we call it as an infinite wire. So infinite wire means what? Up also we have infinite wire, lower also we have infinite wire,
Yes, sir.
bottom side also. So what should be values of theta 1 and theta 2? Is infinity. So theta 1 will become what?
Parallel. No, they can't.
Parallel perpendicular is. I am
Yes, we can take both are having same theta.
what is it? How does it look like? It looks like this. And this is your A. Okay, because it is infinite, I should not draw A this big. So let us say small at a distance I am finding. So above this point also I have infinite wire. Below this point also I have infinite wire.
We kind of take it as the symmetric case.
That is all great. What I am asking, above I have infinite wire. What is the value of theta 1 I am asking? This goes till infinity. That means my hypotenuse is
And
moving.
eventually it will become straight.
this line, right? Hypotenuse.
Yes, sir.
So my hypotenuse is going clockwise. Correct?
Yes, sir.
So when it goes till infinity, what is the value of theta 1?
90 degrees.
That's all I'm asking. Straight, parallel, perpendicular, these words are all great. But what are the values of theta 1, theta 2 is what we are interested in. So theta 1 will become 90 degree, right?
Yes, sir.
Next, what is the value of theta 2? Infinite wire at the
That
bottom.
is also 90 degrees.
That is also 90 degrees. Simple. So in this case, if you focus identifying our, although once you practice it, you will not think of this again and again. It becomes obvious also, but you will not have to think about it again and again. But while practicing it, because it will be new, you will have to focus on theta 1 and theta 2 values while substituting. Sometimes he can give you 45 degree, like the first sub case that we have done. Subtending 90 degree means one angle becomes 45 degree. That angle can be made 120 degree, that not 120 degree, 60 degree theta 2. An angle can be made 30 degree, right?
Yes, sir.
So we can take multiple 37 degree, 53 degree. So
Yes,
we
sir.
have to be well versed with this equation, or you can say this formula, and we have to be very well recorded how the figure looks like in our head.
Yes, sir.
And when we are recording this one thoroughly, all we have to focus on is what is value of theta 1 and theta 2. So 37 degree, 45 degree, 53 degree, 60 degree, 30 degree, all these possibilities are there. Anywhere between 0 to 90, it's possible, right?
Yes, sir.
Okay, so in the infinite wire case, upper side we are going till infinity, so theta 1 is 90 degree. Lower side we are going till infinity, so theta 2 is also 90 degree. So what will that fellow become? E bar is equal to. Before that, I want to discuss one thing over here. I told you just now in the semi-infinite wire to remember the figure, right? K lambda by A, K lambda by A. Actually, if you look at it like that, due to this fellow, we have K lambda by A up.
The K lambda by A horizontally will keep that.
K lambda by A horizontally. Due to upper fellow, we have K lambda by A down.
Yes, sir.
Up down will cancel.
Yes, sir.
How much will be the resultant?
2K lambda by A cos theta.
Correct. So let us just look at it. So resultant will be, we'll substitute and see if we are getting the same thing. Sin 90 plus sin 90, correct?
Yes, sir.
Sin 90 plus sin 90 I cap. Cos 90 minus cos 90 is anyway 0.
Yes, sir.
So j cap will not be there. 1 plus 1. So we are getting the same thing, correct?
Yes, sir.
Is this clear?
Yes, sir.
Xerox. When the figure also, I will just draw this. Here I will have 2k lambda by A in that direction. And if we will understand it from the semi-infinite perspective, this k lambda by A and this k lambda by A will cancel each other, correct?
Yes, sir.
Two semi-infinite wires, k lambda by A will cancel, and in the horizontal direction, 2k lambda by A. Okay.
Sir.
Xerox.
Done, sir.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.